In this video, we will introduce a method for integrating arcsec of x using differentiation. For the function f of x equal to sec inverse of x, the integral of f of x dx is given by the formula x multiplied by f of x minus ln of the absolute value of 1 divided by the derivative of f of x plus c, where c is a constant of integration. Let du equal to 1, then u equal to x. And if v equal to sec inverse of x, then sec of v equal to x. Let's evaluate the derivative of sec of v using the triangle below. This triangle shows an angle V and sec of V equal to x, consistent with what we already made as a statement here. Now we will continue with the derivative of sec of V. Since we said sec of V equal to x, derivative of sec of V must be equal to 1. So derivative of sec of V equal to 1, but we're going to rewrite sec of V as 1 divided by cosine V. Now we have a quotient, so we have to use the quotient rule, and since v is a function of x, the implicit differentiation are also involved. And if we follow the steps, we will end up with the result of the differentiation, which is the derivative of sec of v is sec of v tan of v dv by dx. This is a component of the implicit differentiation. Now sec of v, we can just change it by its value. Sec of v is equal to x, so we replace sec of v by x, and then tan of v is going to be equal to square root of x squared minus 1, so we replace tan of v by the square root of x squared minus 1, and then the component of the implicit differentiation, which is dv by dx. Let f of x equal to sec inverse of x. Based on the hypothesis, then the integral of sec inverse of x dx will be equal to x multiplied by sec inverse of x minus ln of the absolute value of x plus the square root of x squared minus 1. Obviously, this is the reciprocal of the derivative of f of x, as we will see in a minute. Proof. Since 1, let's go back to the derivative of sec of v. We started with derivative equal to 1 and we ended up with x multiplied by the square root of x squared minus 1 dv by dx. So we can take 1 equal to this value, and since that is the case, we will solve for dv by dx, and we will get dv by dx equal to 1 divided by x multiplied by square root of x squared minus 1, and this is actually the derivative of v, that means the derivative of cosine inverse. And if we get the reciprocal of this, we will get what we just mentioned that we're going to explain. So that explains this value that we have right here. Now we will proceed. Since we said 1 equal to x multiplied by square root of x squared minus 1 dv by dx, we have to solve for dv by dx, and that's going to be equal to 1 divided by x multiplied by the square root of x squared minus 1. This implies that dv, if we solve for dv by multiplying both sides by dx, we get dv equal to dx divided by x multiplied by the square root of x squared minus 1. And we could also conclude that dx equal to x multiplied by the square root of x squared minus 1 dv. We will need both of them in a minute. Using the product rule of integration, which is right here, the formula, we conclude we have the values for each and every one of these. We'll just plug in the values. Integration of 1 multiplied by sec inverse of x dx, that's our function, equals to u multiplied by v. Our u is x, our v is second inverse of x, minus integration of u dv. Our u is x, our v, we said that dv is equal to dx divided by x multiplied by square root of x squared minus 1. So this is our dv and this is our u. Now we can see that the x will cancel the x and we will be left with integration of dx divided by square root of x squared minus 1. From the triangle, we know that x is equal to sec of v, because sec of v equal to x, so x is equal to sec of v. Now that we know that x is equal to sec of v, let's go ahead and replace this x squared by sec square of v, because x equal to sec of v, so x squared we replace it by sec square of v. But then sec square of v minus 1 will be equal to tan square of v. Now we can get rid of the square root, and this will give us integration of 1 divided by tan of v dx. We will continue integration of 1 divided by tan of v dx. We cannot integrate a function by reference, that is x, when the function is function of v. So we have to figure out the equivalent of dx, and we already prepared that. Dx is equal to x multiplied by square root of x squared minus 1 dv. So we're going to go ahead and replace dx by its value, which is right here, dv. Now we will go ahead and replace x by its value. X, according to this triangle, is sec of v. So instead of x, we're going to put sec of v, and instead of the square root of x squared minus 1, we're going to put back tan of v. So we have here sec of v, tan of v. We know that tan of v will cancel with tan of v. We'll be left with integration of 1 multiplied by sec of v. That means just integration of sec of v dv. Now we have this integration. We have to perform this integration. So integration of sec of v dv equal to integration of sec of v multiplied by 1. But our 1 here is just sec of v plus tan of v divided by sec of v plus tan of v. Now, if we multiply the numerator by sec of v, we're going to get sec square of v plus sec of v multiplied by tan of v. And the numerator is the same. But then we can really tell that the numerator is the derivative of the denominator, and as such the integration will be ln of the absolute value of sec of v plus tan of v. Now we have to put back the values of sec of v and tan of v. So our integration of sec inverse of x dx equals to x sec inverse of x minus ln of sec of v plus tan of v. But we know that sec of v is equal to x from the triangle, and we know that tan of v is equal to square root of x squared minus 1, absolute value, and ln. That's plus x. We can see that this is the answer, and this answer is consistent with what we gave here from the formula. So the formula worked fine, and thanks for the shortcut of the formula. We don't have to go through all of these steps. This is just, we have to remember that this is the formula and just plug in into the formula and we will get the answer. That's it for this video. Thank you for watching, and if you liked what you have gone through, then please subscribe of our channel. Thank you and have a great day.